All right, so our next session is on shaping the future of data, accessibility, and transparency for action. And to introduce myself, I'm Langley Dewitt. I'm the director of the International Global Atmospheric Chemistry Project, which is based in Boulder, Colorado, and facilitates international networking and collaboration. And if any of you are early career scientists interested in attending our conference next year, put in a little plug, talk to me. We have some travel grants for that in 2024. So data access to, we've heard a lot about how poor air quality affects public health, it affects agriculture, it affects, ecology. Access to trusted, scientifically valid data can play a transformative role in the discourse on air pollution. And in different contexts, the purpose or application or use of this data varies. So, a mother might look at the air quality data to see if she wants to take her child just walking to school or not. Can I go for a run? For others in the policy context, the data, can be used to meaningfully create data-backed policy to mitigate air pollution. Transparency can also foster trust and help strengthen accountability for action, especially as new policies and programs aimed at improving air quality are launched. And so this keynote panel will discuss principles of data access and transparency and provide a perspective on current status and best practices, as well as opportunities to expand global infrastructure, access and usage, and practical examples from Africa and beyond on accessing air quality data. The experts will discuss important technical and social considerations, current barriers and possible solutions to those barriers, and the panel will close with an interactive discussion as they have been in the past. So get your questions ready for the panel as you listen to their talks. And the first speaker is Dr. Christa Hasenkopf. She is currently the director of air quality programs at ASIC Chicago, and she's based in Munich, Germany. And her career focuses on efforts that open up information, resources, and networks so that more people in more places can help make the air they breathe healthier. And previously, she was a co-founder and CEO of OpenAQ, and she's also worked for the State Department, USAID, and other air quality-based organizations. And so take it away, Christa.
Thank you. And as my slides are coming up, just to briefly introduce myself and give a little context. As Langley said, my name is Christa Hasenkopf. I'm at the Energy Policy Institute at the University of Chicago. And if you're not familiar, this is an institute within the University of Chicago that houses several different efforts that focus on, in one way or another, addressing the global energy challenge. And I'm doing that through the lens of air pollution. But most of the other people I work with are economists. I think all of them are, actually. I'm an atmospheric scientist by training, and as was mentioned, care deeply about open data and open source initiatives as it relates to air pollution. And increasingly over the past 5 years or so, very interested in the funding space and the support for air pollution as a global issue. And with that, go to the next slide. And so a brief outline for the talk. We'll share a few slides on level setting. What is fully open air quality data and why does it matter, especially in the context of filling data gaps, the current state of global air quality data and other air quality resources. I'll share some readouts on interviews we've been having with local actors across the world on barriers to monitoring and data sharing, and then end with what I think are a few golden opportunities to build global infrastructure to accelerate open air quality monitoring. Next slide. All right, next slide. So just to have the same language that we're talking about when we're referring to fully open air quality data, a lot of ways to define open data. But I think in the air quality context, here's 4 criteria that I've relied on. These were developed at OpenAQ in 2020 and 2022 in State of Global Air Quality Data reports. And these were initially developed for government data sharing. So 1, the data that's shared should be physical. You could have data that's also shared as an AQI or other metrics, but at the end of the day, you need to also make available the physical data. 2 station-specific information and including coordinates, so you know where the data originates from. This may seem obvious, but there are, for example, countries around the world that do not provide this information, yet provide the air quality data, the value, so you don't quite know where that data originates from. Number 3, timely, fine spatial temporal information is available, so less useful to have yearly data, way more useful to have sub-daily data. For a lot of use cases. And then 4, this was brought up a few times by several different groups, but programmatic access, or the data being available via, say, something like an application programming interface, an API. This makes the data buildable upon, so that people can build all kinds of efforts downstream of you. And then, in the context of non-governmental sensing or lower cost sensing, I'd also say that the data needs to be shared or at least pointed to in a place that people know where to go to get it. Otherwise, your data kind of just sits there. I think of this like a dictionary. You could come up with the coolest, most powerful, interesting new word. But if it's just something that you know about and you don't share it in a dictionary, no one's going to find it. So you need some sort of place to capture where this information exists. Next slide, please. And so why does open data matter, especially in the context of places with little data? So some of this we've heard from other talks, and I won't belabor the point, but essentially it's an essential building block for policy action at the national level, for example. So this was a really interesting study by Candice Balsing and Kirk Smith about 10 years ago, where they looked at ambient air quality standards in 93 countries, and then very interestingly interviewed the people behind those standards. And they found that air quality monitoring data was used most often to establish or revise ambient air quality standards. I think that's super powerful. And then you see that's followed by environmental epidemiology studies, which in part often rely on epi studies. Next, rely on open data. So in this slide, I just added it based on Professor Kofi's comments today about epi studies and the dearth of them across Africa. So this is some data we've compiled. We looked at 193 studies of large cohort. This was, I believe, 1,000 people or more studies over a certain, I think at least a year long or longer time period for PM and mortality studies, epi studies across the world. 84 met the criteria, and here's a map of where those 84 are. And you see the blue dots are representing where there's 0 epi studies. And in part, not fully, but in part, this is due to a lack of data. Next slide, please. And so the other point I'd make about national level impact is the amazing thing about having even a little open data, especially in places where that doesn't exist, is that you really can spur national level movements that provide sustained political will for clean air by even a small effort or even a single monitor in some cases. I give 3 examples here. I bet many of you are familiar with a good chunk of them. One includes, the one in Pakistan includes work from just a very low cost sensor. I think it was Air Visual. The embassy example in China was a reference grade monitor. And this one here in Mongolia was a research grade monitor. And the point is that these efforts relative to the change they brought to air quality management infrastructure, policy, and in some cases, actual declines in pollution, far outweigh the cost of the actual issue. There's not a one-to-one line where either any of these initiatives are fully responsible for that impact, but definitely worth their weight, I would say 100 times or more over. For example, in China, the data pushed by the embassy and several other efforts helped push for policy action that over an 8-year period has declined PM 2.5 annual average values by 42%. That's incredibly valuable. And if that one monitor even played 1% role in that, that's an incredible return on social investment. Next slide, please. This is mentioned already several times by Rajima and Garima and Dan around international or cross-borders impact, and a few others around having data and data gap areas to improve our estimates of PM 2.5 around the world. And I'd also say, though, that if you have a little bit of data, and I think this is something Cosmos brought up, if you have a little bit of data in a place where it wasn't before, that data can be anchor data, and it brings in other projects, interest, and research to that area. And then the other thing I'd note is we also want to fill these gaps because it reduces geographic bias in so-called global air quality analyses, where if you look under the hood, you see that a lot of the data does not come from the global south. And this is becoming even more important when you consider ML or AI analyses, where that under the hood, where that black box nature is even harder to discern by a human. So the next slide, please. And this one I left my animations in to sort of make a point. You'll have to click 9 times. But I think both what you've seen here at this meeting and heard over and over and over and over again, you can keep clicking until you get to one right in the middle. I'll let you know. But we hear again and again that this data gap issue is a problem, and it's a no-brainer for us to address. It's just a matter of finding the funding. So you can keep clicking through. All right, so now on to the state of open air quality data landscape and other resources. Next slide, please. So we've seen some version of this a few times to past 2 days. So this shows where air quality government data gaps are. So in the orange, the dark orange, is where there's no known, or at least as far as this report could tell, no known government air quality monitoring. In 75 countries, in yellow, that's where the data is not fully openly available according to those 4 criteria that we saw in the beginning. And you see 4 gap regions highlighted that you'll see repeated over and over in different views that we'll look at. Next slide, please. So this tries to capture where there's no non-governmental open air quality data available, at least as a proxy using data from OpenAQ. And this shows in red where there's not evidence of even a single, at least according to their platform, not a single non-governmental or low-cost sensor monitor, which I thought was interesting, and it tracks with those gaps, of course. And this slide is courtesy of data shared by the Clean Air Fund, and it's country-level information on where there's international development donor gaps. This is international development donors as opposed to, say, philanthropic foundations, just to distinguish. This is out of a $2.5 billion USD pie. And you'll see that everywhere in red is where there's less than $100,000 in funding for those countries. And I think of 100,000 is not adequate for long-term running of a BAM, say, but it's a chunk of money that would buy you that instrument. And so it's a nice threshold. So to capture all that in a different way, this figure shows the regional share of life years lost due to PM 2.5 globally. You see Asia and Africa, a subset there in dark red showing excluding India and China. And then you see the Europe, US, and Canada. And then if you click, you see this trend is exactly reversed for where there's percentage of countries in a given region that has fully open air quality data. And if you click again, you see it's reversed still for the regional share of all philanthropic funding for air quality data from a 2021 report. And so there's a profound disconnect between where the problem is and where we're investing to do it. And I would say the even larger problem is the pie underneath this that just simply isn't big enough. All right, so now we're going to shift gears to share some challenges we've been learning about and we've heard and experienced, and many of you have shared in the past couple of days about local actors to fill this data gap. And I'll emphasize this is a public registry that EPIC, the Energy Policy Institute, is collecting to highlight local actors doing this work. It's still open. It takes 5 minutes to fill out. We do follow up with some folks for an interview, but this takes 5 minutes to fill out. There's a QR code, there's a URL, and there's also a poster over there in blue. If you're interested in filling that out, we'd love to hear from you. So some context, though, behind it is we have a new program at EPIC that is working on air quality data gaps, specifically in figuring out how we can be better supporting local actors monitoring PM 2.5 in countries with pronounced PM 2.5 data gaps, and even defining that. I think most of us in the room are like, yes, we know where the data gaps are, but the truth is a lot of other stakeholders from international organizations, governments, and donors don't. and it's not spelled out for them in a way that they can really act upon. So our goal in this report is to make something that is at the country level, really spells out where there's opportunities for potential investment to have a small effort be sustainably funded and have a potential national level impact. So here's some, just a quick profile of who we've been hearing from. We've had 73 responses so far. We've heard from 32 countries. We've heard from researchers, nonprofit folks, activists, informal entities, no government respondents yet. And we're conducting interviews, as I mentioned, and Farah Kazi has been leading that work, and we'll share some insights from her work so far. Go to the next slide. So just a sampling of activities we've heard about. So for example, we've heard from several of you in the room. We've also heard, for example, from Cote d'Ivoire. There's a tech agency. They don't do anything with air pollution. They've set up a PM 2.5 sensing effort as a self-funded social good because they thought it needed to be done. In Bangladesh, we've heard from a researcher who has previously set up monitoring in a refugee camp and is working on creating a DACA-wide network, which is really exciting given Bangladesh, by PM 2.5 annual average standards levels, is the most polluted country on the planet. In Colombia, we've heard from an electrical engineer who's built his own device and scaled it across Bogota and is now working on an initiative to do work in schools and involving 450 sensors across the city. So this looks like it got a little screwed up, but some challenges we're hearing, and again, have been oft repeated here in the past 2 days. One is around credibility. How do you know the data, what the data is fit for? How good is it? Difficulties sharing their data, different companies having different data sharing ownership or sharing policies, academic issues around sharing, and expensive air quality data as a service programs. We've mentioned several times difficulties accessing good reference data, funding and capacity limitations. Again, we've heard not just from monitors, but also for the staffing it requires to host them over the long term. A lack of funder focus. We heard funders get disinterested after a year or two, which I've already heard several times here and have heard at many different conferences over the years. And then the thing that I've heard that is very interesting and seems like low-hanging fruit is a repeated point that a lot of folks just want to be amplified and connected to the international community. Some have even said, not most, but some have said, we have funding, but what we don't have is a community to engage with, and we don't know how to connect with it, and we want our work to be amplified and it to be used in a variety of different contexts. So to wrap up, here's some golden opportunities we're thinking that investing in global infrastructure could do to accelerate clean air action. So one resonates with, I think, Subu's comments, is to invest in open source air quality data management software in infrastructure, especially appropriate for small or medium-sized deployments. A lot of the existing software has been designed for much larger government scale work, and this could include anything from QA, QC stuff, data sharing, analysis, but the idea is that the transparency and the existence of it being in a shared space allows it to be adoptable, but also importantly, adaptable to a local context. And I don't think this is, there are several efforts. There's one main effort underway currently exploring this, and I don't think it's rocket science, but it's more about coordination, which can be harder than rocket science in a lot of cases. I think this would have benefits of addressing credibility, so the end user doesn't have to figure all that out or get that credibility. They have a system that helps them gain that. It helps with data sharing, so that you take away that undifferentiated heavy lifting of figuring out how to share data. And would overall reduce the cost and time and technical capacity needed to start monitoring. And I also think we saw this through OpenAQ a little bit, that it creates the environment for data standards and protocol standards almost by default. And number two, I think there's an opportunity right now to support and advocate to sensing manufacturers to embrace open source software and hardware. There's an initiative out of Thailand working on this, a company. I find it quite bold that they're making their entire hardware and software open source. And there's the same benefits as above for open source air quality data management software, but you also get to improve the ecosystem faster. I'd rather be part of an effort that maybe is imperfect in the beginning, but if it's open source and has a way of getting shaped by the community, it will advance further in the long run than, say, something packaged a little bit better in the beginning, but doesn't have that same feedback loop. And I think it also can push, say, private sector initiatives to provide value outside of black box algorithms. We saw this with OpenAQ too. In 2015 or so, it used to be a value add that you knew how to scrape government data when free or nonprofit initiatives take up that work instead. That becomes less of a value add and sort of pushes the whole ecosystem to provide a little bit more value in general from especially the private sector. And then lastly, or actually there's two more. Third point, organize a community of practice so communal resources and learnings can be maximally used. I think we're seeing this with ASIC, for example, perfectly. I heard yesterday someone mentioning how they've discovered that there's, who does not live that far from here, that there's a reference grade monitor in Okure, and that's super important to be able to surface that kind of information so that, again, like for the resources that exist, you're maximally using them. And then the fourth one, the last one, to the point of the last barrier I mentioned on the previous slide, to amplify the value of open data sensing work, both done by the individual and our collective work outside expert circles. This is something Gabriel actually said a little bit about earlier. I think we need to have better strategic and systematic ways of drawing attention to air pollution, to open data work around it, so that we get the resources that we need from whether it's policy development or philanthropic circles. It truly is the case that the pie is too small. And it's not just a matter of complaining about the funding circle, but I think finding strategic ways to address it. So, for example, yesterday during lunch, we were having a conversation about, one of the things within the U.S. government is there's a $30 billion or so global health pie. Air pollution gets practically zero of it, and that has to do with Congress and it not being of interest. Part of the reason it becomes of interest is if there's folks lobbying for that. There's no one lobbying on the Hill in the U.S. scenario for air pollution from an international development context. That could be resolved. That's like 2 or 3 people, and I think it'd be a very well worthy exercise to invest in that, potentially unlocking literally billions of dollars. And even if you end up getting a couple $100 million, that would dramatically change the current landscape for air pollution funding internationally. And with that, I'll just point that I think this conversation will continue tomorrow in the funding section. And the last slide. Thank you all. And if you're interested in receiving a copy of that report I mentioned, please let me know. You can send me a one-line, just a subject line email that says report. My email's there. It's also on the poster. And thanks so much.
All right. Thanks, Christa, for highlighting where the data gaps are and what you might do to address them. Next speaking is Dr. Mead, who's from the Imperial College in London, and he's the head of air quality measurements in the ERG team. And as part of this role, his responsibilities include the London Air Quality Network of reference grade monitors, as well as a Breed London hyper-local community sensor network. And I believe he'll be talking about the value of understanding, creating, and sharing the quality of data and of metadata as well. So maybe.
Near enough, certainly. I actually don't have a structured, formatted talk as such. I wanted to raise some points in preparation for the panel discussion later on. I wanted to start asking some questions now so we can have a wider discussion amongst ourselves for this community of practice. Okay, I'm hoping he's miming moving close to my face because otherwise it's disturbing. So the first thing I wanted to do was remind people that there is an established air quality management cycle. This is the diagram taken from the US EPA. The key thing is making the measurements is part of that cycle. If we don't integrate that effectively with the wider system, as underpinned by scientific research, we're essentially not going to move anything forward. If we don't understand what is being produced in terms of data, we aren't open with that sharing of data, it's going to be very difficult to change the establishing goals step, because that shouldn't just be in the hand of government. That should be a community-driven, a bottom-up advocacy to allow us to make that conversational change, which then forces the emissions reduction conversation, which then frees up funding regarding control strategies, implementation programs. And it's a virtuous circle, but it has to be pushed. One thing that's interesting, especially with the funding conversation, is that national monitoring activities are in many cases constrained. If you want to change or improve a nationwide monitoring network, you have to overhaul the whole thing. It's a huge endeavor. It takes multiple years, and it has government involvement. It has sheer momentum behind it to make any changes before it's accepted and rolled out on a wide scale. As a result, cities are becoming the focus of both air quality and climate goal setting. There's far more flexibility at the city scale than at the national scale. And that's also something that can be influenced far more. But as you said, there are individuals or smaller groups can make direct impact at that scale. And for that, we need integrated local needs-driven observations. Next slide, please. So one of the key things for generation of hyperlocal data is this concept of identifying hotspots, source apportionment. This allows us to look for individual sources or source regimes in our domain that we can then take action on. So as opposed to just saying we need to reduce NO2 by 15%, we can start having a conversation regarding zoning, industrial activity, traffic numbers, schools, street zones, these kinds of things. We can have a wider conversation after we pinpoint sources and how they're transported as well. We mustn't forget that it's not just where the source is, it's a transport element as well. And that will enable us, especially in more developing economies, that will enable targeted, cost-effective and impactful strategies to improve air quality, as opposed to a broad scattergun approach where you just think, right, we have to change the whole vehicle fleet. Actually, we should be looking at local solutions for local problems. Going to the open data point, having the data shared is very important, and having it available, historical data and current, is critical. But also, I think we need to be having a conversation about traceability and calibration. We need to be opening ourselves up to criticism in many cases, but certainly scrutiny about how we're working up our data. We need to be completely open about what it's taken to go from sensor output to sensor human readable number at the far end. Black boxes are a difficulty because they remove a certain amount of confidence in the data processing stream, which then takes you outside of what is the traditional regulatory regime. That is to say, a government or an agency has a known protocol for operation of an instrument. It has a known protocol for the specification of that instrument, and you know what you're doing from day 1 to month 6 to year 2, whatever it happens to be. It is comparable because you know what's happening at every step. Low-cost sensors don't have that. Without it, it's going to be very difficult to share compliance infrastructure. And if we don't have that traceability of standards and methodologies, confidence in what we're saying in terms of pollution levels, it's going to be very hard to generate, especially when it comes to the regulatory conversation. Next up, please. I wanted to throw up the Breathe London work we're doing as an example of citywide monitoring, but mostly as an example of the issues that can be associated with a requirement to have open and shared data. That was a fundamental part of the establishment of the Breathe London network. It wasn't to get more sensors out. It wasn't to get more numbers. It was to have a resource for Londoners to provide socially actionable data, which is also scientifically useful. Yeah, that as a mission statement it's rather well crafted by someone else, I have to say, but it's actually true. The whole point is we had to have a system which was scalable by agency, by individual, by grouping. And to do that, you have to have that data open sharing attitude at all stages in terms of why you're doing it, what you're doing, what it means. Next up, please. So just to reiterate that point, individuals are involved, community groups are involved, businesses, local government, they can all be involved in that network. But as a result of being involved, we'll leave the mechanics of that to one side. Kayla will be talking far more about that tomorrow and in far more detail and far more eruditely. The key thing is all of these groups have a different need in terms of openness of data. The concept of just saying my data is open because it's on a web page, you can download it, is not the same thing as saying the knowledge generated from that and the actual information is open. This has to include going right back to hardware and the processing side of things, as well as what we intend to do with it and why we want to do more or expand or whatever it happens to be. There has to be a philosophy behind it beyond data, web page, download CSV. Next slide, please. This is the current network. That's where it started in the bottom corner there back in 2021. We're about 422 sites currently, and that's in partnership with about 110, 111 reference sites. We're very lucky in that respect that we can build this network, but the core funding model for this, 130 nodes or so were funded by the London Authority. 60 nodes were funded by Bloomberg. Well, 130 plus 60 doesn't equal 422. The reason we've had this expansion is our funding model is based on inclusion of wider groups. And for that inclusion, we have to have openness. They have to buy into the philosophy of what we're trying to do and understand the value of it and actually get value from that network deployment for them and their wider community, whatever that value happens to be in their case. That's what's enabled it to grow, and hopefully it'll continue to do so. Next up. Access to the knowledge is critical. As actually pressing download CSV is actually a very useful feature. I shouldn't knock it too much, actually. But the work that's being done at the ERG is based on about 28 to 30 years of providing information for Londoners via reference instrumentation. The network didn't appear overnight. It started out with 1, 2, 3 sites as a scientific endeavor, and it grew, especially as awareness of pollution and challenges was more widespread, more available. And then we started talking about, before my time there, how air quality should be managed. That's a conversation with policymakers. What it means for individuals, that's a conversation with communities. Again, Kayla will talk far more about that tomorrow. But the various ways of getting information out there, there's been some fantastic examples of that data sharing shared over the last couple of days of how people are talking and how people are getting that out there. And it's fantastic to see and hear about that willingness to get the message out. I mean, that's a sign at a tube station, community groups, we have meetings, webinars and sessions and apps and maps and all the usual suspects. But the key thing is there's no one size fits all. It's what does a community group need? What does that business group need? What does that government agency need? What does that borough need? And trying to work with them for them, as opposed to just saying, here's the website. Next, please. Engagement with communities. I am not going to touch on this, Kayla, don't worry. I'll leave it for you tomorrow there. But it's real engagement. They get to choose what the question is they want to answer. They get to discuss with us where they want to put a node, and we provide guidance on that node installation. But the fundamental point of that node being there to answer the question that they want to ask, not that we want to ask. If that means the node is technically suboptimal in terms of a scientific question, it means that it's optimized for a community question. For example, a school street. Should we have a playground area? Are we worried about this bus stop? Now, we all know that if we're worried about a bus stop and pollution, move the bus stop, make sure the buses are cleaner, make sure they move faster, whatever it happens to be. Those are the scientific solutions. But for a local community group, having that information is engaging with that group and allowing them to make decisions and behavioral change at their pace in their way. Lots of pictures, and Andy and Kayla are doing fantastic work on the community side of things. I do like the logo for Breathe London with the smiley faces, but occasionally it does freak me out a little bit. But apart from that, I think it's all right. Next up, please. This plot is from Zhang et al. We can talk about the underlying data user generated, but fundamentally the point of it is that as we have an urbanizing environment, we can take that as a proxy for a more engaged community, a more engaged populace with the question. We have an increase in air pollution levels associated with the hive quality of human beings we provide. We group together, we generate pollution. But the public concern line and the actions on pollution control, one lags the other. But you have to have that public concern, you have to have that advocacy, you have to have that messaging out there. That's not a policy question, that's a ground up point. And then you can start advocating for change with our governance systems. And hopefully then we'll start following this black line for urban air pollution and it starts dropping off. Most cities across Africa have a wonderful opportunity to leapfrog and avoid the mistakes that we made in Europe and North America in terms of how we develop our cities and how we control our pollution. It'd be fantastic to share in, say, 3, 4, 5 years stories of people in this room who have made that change and have enabled a avoidance of the peak of that black line, whilst enabling that good growth question as we evolve and grow as communities. Last slide, I hope. And this is for the discussion session there, unashamedly personal. That's my great-grandmother, my great-grand-aunt. This is in Tabora in northern Tanzania. And one of my jobs when I was a kid was, we lived in a compound, a multiple sub-families, so uncles and aunts and cousins and everything like this. And all the cooking was done on 3-stone stoves outside using charcoal, usually from blackwood, because that was the best stuff for cooking with. But she ruled the compound, and all the cooking happened in one corner at one time of day, so all the smoke was contained. And the vumbi and moshi, smoke and dust. The dust was because the ground is sandy. I had a tin can, which was old paint tin, and they used chuma to make holes in the bottom, filled it with water, and my job was to walk up and down, spraying water on the sand every morning to make sure the dust didn't build up and get transported into the house. Those were her air quality concerns, smoke and dust, that's it. How is that so different from our conversation now? We're a bit fancier about it, but and that's my son. I'm hoping he doesn't have to ask those same questions because he's already asking awkward questions. I don't need any more. But I'm hoping this is a conversation that's a historical one that we look back on and we talk about, like, oh, oil, we used to burn oil. Did you know that? We used to have this polluting system. We didn't used to measure air quality in our town at all. Can you imagine those crazy old-fashioned days when they had VHS cassettes? I want it to be of that level of conversation. And I'm hoping that in the panel session later on, these are the sort of points that we can discuss regarding the needs and the importance of open access to knowledge, information, and advocacy.
Thank you very much for that really great talk on, how to share data and the impact of sharing data. And our last but not least speaker is Dr. Engineer Bainomugisha. And I think you've seen him already, but he is the lead of AirQo, one of the exhibitors here. And he's an associate professor of computer science and the chair of the Department of Computer Science at his university. And he focuses on computer science-driven solutions to prevailing world challenges, such as air quality. So I think he's gonna go ahead.
Great, thanks, Langley, for that introduction. I think this session, one of the questions I'm trying to ask is, is data accessibility, the key to unlocking, Africa's clean air future? So let's see. Next slide. I think a lot of this has been already, answered. Like, what's the goal of improving, air quality data access? Why do we have to improve access to air quality data? And I think there are many reasons. Next slide. Well, I think broadly, or in a simplistic way, we could say that we want to increase access to air quality data to empower someone to hopefully take action and improve air quality for all, which will probably save, lives and many other benefits. So in the question mark box there, I think you could place in different stakeholders. If you're here, from government or researcher, I think you can see that improving access to air quality data should empower you to hopefully take some action to deliver some of the benefits that have already been mentioned in the previous presentation. Next slide. Yeah, so just to maybe, again, in a simplistic way, trying to model this, I think we all agree that data that's not accessible is not valuable. So we can say that data is only as valuable as accessible. And I think, as you can see in this kind of, plotting here, I think the extreme, what we'll all aim for is that we have maximum access and we also have maximum utility. That's the ideal situation that we can do. But we know that many things happen along the way. And I think many times we are, many challenges, circumstances might try to drag us towards the no access, but which then means no utility. So hopefully we can try to go in or stay into that acceptable range of where we can balance the accessibility with the utility in the different, either sense networks that we're trying to set up or the different initiatives that we're trying to do. The question is, how do we work together to ensure that we actually, try to achieve the acceptable balance? Next slide. And together try to avoid, being in that trap of, no access, which ultimately means no utility. I think regardless of how good the data is, you might, but if no one has access to that, then yeah, we can say that this is of no use, and maybe we should try as much as possible to avoid that. Next slide. Yeah, so I will spend a bit of time on this slide. I think many times when we talk about data access, for some stakeholders, we might fall somewhere in this graph. So on the first picture, extreme left, is like a sensor network. You have a physical network, and for some people, data access actually might be at that level. Then in the middle there, we have this data coming in from different networks. You have a lot of data management tools trying to make sure that this data is actually accessible. Again, you have a lot of people who when you talk about data access, but it might actually fall under that category. I think the majority of the people might be at this extreme end here. So when we talk about data access, I think the assumption is that this data already exists. So I just want to have access to data. But then you also need to think about that, this data doesn't just appear at this level. Somehow it has to go through this chain. So on one hand, you have to set up, a sensor network. I think we all know the effort that is required in terms of setting up the sensor network. You need to maintain this sensor network. You need to ensure that this data is, accessible. So if you're a network engineer, you probably think about data access is their ability to harvest the data from the devices. This could be manual or could be automated. So for you, accessing that data at that level might be important. But on the other hand, if you are maybe a government official, you are mostly interested in this level. Can we get the data analytics from this sensor network? But on the other hand, there's a lot of work happening in the middle there. As you get the sensors, just imagine you have 200 sensors. Well, so you have 100 sensors. Each sensor sends maybe data every other 1 minute. So if you compute maybe within a year, you might have about within a month, you might have about 2 million records of data from, just 100 sensor network. Within a year, you might have about 25 million records of data. So just imagine, that data coming in through, at a very high speed in numbers. So you need a lot of infrastructure and support to actually make sure that this data is accessible. And if you're setting up, sensor network, then you need to start investing in data infrastructure. You might opt out to put this data in a cloud. But again, putting data in a cloud, it comes with a lot of, bottlenecks. There's cost involved. You need expertise to be able to actually ensure that, the cloud system is well set up. You also need to ensure that as this data is coming in, we've been talking about, quality assurance, it's calibrated. You do not expect people to download the data and calibrate it. You want to ensure that every data point that comes through the system is being calibrated. So actually doing the engineering work to ensure that this entire pipeline works as expected. There's a lot of hard work. So this is a reflection to all of us. When we talk about data access, then we kind of need to reflect and look at the entire pipeline and see how are we supporting the entire system to work, because you cannot have the data here either in the API or the mobile app or dashboards if someone is actually not going out down on the ground and maintaining a sensor to provide that credible data. And then, of course, building a lot of tools to ensure that you can have visibility in each of these levels. Next slide. Yeah, so last month we had a very kind of diverse stakeholder workshop. This was in Naivasha in Kenya. And in the room we had, several stakeholders. We had people from, government, had academia, civil society, and so on. And we asked, the group of people who are in the room, as we said, are you a data producer or are you a data consumer? And then we asked each group to, provide insights on what they think, like the major barriers around data access. And these are some of the insights that came through from that. So many people indicated, that the cost of collecting data and managing the data is actually significant. And some stakeholders, did ask, say, much as we ask for data to be openly accessible and available, they say, if it's not free to collect, why is it free to share? So this was a point of reflection for, the team. And then there was also other challenges identified, such as the narrow scope or the purpose of the data. So sometimes the data collectors have like specific purpose. They want to collect data to undertake a specific study. And beyond that, they're not looking at sharing the data outside that. And of course, you also have restrictions with the institution that the data cannot be shared beyond the institution boundaries. There are also, concerns around regulations, data privacy. Many countries now are putting in place, regulations either at the local level or regional level. I think the point of capacity and skills has already been raised. Even the skill to be able to ensure that data is actually shareable is important. There are issues of prior agreements that some networks have put in place with specific agreements to say that this data is only accessible to these groups. And then what happens if another stakeholder comes on board to access the data? And then, of course, there was also a fear of misuse. This is also, mentioned within the discussions. Next slide, please. Yeah, so beyond these challenges, what can we do to improve, air quality data access? So I'll share some thoughts on this, much in line with what has been said. Next slide. Yeah, so I think key to this, what we see is we need to build, of course, local capacity, skills, and also have resources to be able to actually set up and maintain physical networks to be able to collect this data. I think the point of open software and open platforms has been mentioned quite a lot. I have to say that, building and maintaining a credible open source tool takes a bit of time and requires a bit of effort. It's quite easy to say, we want to build an open source tool, but if you don't have an organized community to maintain it, provide leadership, ensure that there's quality control, it can also be quite difficult to manage. But the good thing is that there are already, many other projects we can learn from. Open source platforms have been very successful, which I think building open air quality data software tools will be a good starting point. Here, just an example for AirQo. So AirQo, by default, we emphasize on adopting open source technologies across our entire pipeline. And this is one of our software, repositories on GitHub. So everyone who has the ability to write software can actually enroll and subscribe to our Git repo and can contribute. We have a number of like open source modules that we're focusing on, starting on the the visualization, the calibration, and also some parts of the hardware. So everyone is, of course, welcome to contribute as well, but also clone the repos, maybe customize them for their own use. The capacity to do sensor development as also the evaluation. I think this has been already touched on in the previous sessions. And so I think we see the emerging works on, let's say, sensor evaluation at AfriSet. I think the more examples we have of this, the more it becomes easy to improve the credibility of the data, but also increase the access of the data. And then, of course, the power of the networks, which had also been mentioned. I think ASIC, ANGA, CAMSNet, CLINE, and many others. All those are good initiatives. Next slide. Yeah, I think the key component of when we talk about low-cost sensors is definitely issues around, trust and data transparency. And I think we can partly achieve this through, building explainable and reproducible quality assurance processes. So this could be, having, common calibration standards or data modeling and so on. At AirQo, we've been, trying to contribute to this, scientific knowledge as well. We published papers on, using machine learning for calibration and also using Gaussian process models for calibration. All these papers are also available online, and we hope that other teams can also take the same calibration models, and use them, but also have reusable software modules for the same, which can be, cloned from our GitHub repo for use in, different settings. And I think it's also important to ensure that we demonstrate the value of air quality data to, different groups. And I think to be able to do this, we need to, of course, bring on board different disciplines here, machine learning, data science, user experience design, atmospheric sciences, and so on. In Kampala, we've been trying to build, communities on machine learning, but also broadly across the continent. We've been contributing to Data Science Africa, which is like a network of, several countries around the continent who are trying to bring together, people from different disciplines to, learn how to do data science and machine learning. And of course, most importantly, aligning with national regulations and data governance when it comes to open data access. Next slide. Yeah, and finally, I think as we discuss the issue of data access for air quality, I actually look at it as partly a solved problem. I think when you talk about data access, it's not really restricted to air quality. I think when you look at all the other elements of data, it's be it in environment or be it on data about maybe the population, I think in general, there are already well-established principles on how we can actually increase data access. And I found this, fair data principles already, published and available, which is, very, very simple concepts that data should be findable, accessible, interoperable, and reusable. I think if we adhere to these principles, then we should actually be able to achieve improved data access for air quality. Thank you.
All right, thanks for those insightful and specific examples of ways to make data open and accessible and fair. And now we go to the interactive portion of this discussion. So does anyone have any thoughts on how to make data more open, challenges you've had, barriers, how to cross those barriers?
Just some reflections also on how to make the data more open. Currently, a lot of the data is stored in silos. Even if you believe it's interoperable and you adhere to the FAIR principles, still we don't have standard APIs. Everybody has an API. That doesn't mean that it's the same and it's usable, because then you have different ontologies and different semantics. And at the same time, also we work on the different processing levels. It needs to be in a structure there. What Ike was mentioning, also you're treating the data and that's okay to have corrections and calibrations, but the user should be aware of them to be transparent. So here my question, we are currently working in a project in Europe to create these standards, and we want to do that together with the community of practitioners. And also, Katin, you was mentioning also to do these communities of practice. So how do you see a way forward to create these communities of practice where we can talk and discuss and kind of start agreeing on a standard, or how to make this metadata, what can be this ontology and semantics that we can use, what should be in the metadata, because it seems like you say, it's not rocket science, but seriously, when you go to the nitty details, wow, it's become so complex, to get these agreements. So yeah, how do you see the way forward?
Okay, and I think there's another question around here. I'll take two and then we'll go to the third. And then they'll answer.
Thank you very much. Once again, Professor Iwana, I seem to be having some wild thoughts going on. I don't know whether this will relate particularly to this panelists. But as they were talking, these thoughts were coming to my mind. One of them is that most of our discussions have been on PM. And we've used that to characterize the quality of air in most places, and sometimes publish them. I'm getting a little bit worried that unless we want to say that PM will correlate well with other pollutants, shall we not be faulted someday that places that we have declared healthy on account of using PM 2.5 may actually be heavily polluted by other parameters of pollution, maybe gases? Is there not a concern there? Should that concern not be addressed in developing low-cost sensors so we can have a more dependable and reliable source of information? The other one, number two, is a concern that data access may not be synonymous to information. And I have reasoned that participants who may not be very familiar with most of these procedures for data analysis, maybe programming methods, should be given opportunity in conferences of this nature to know how to transform data to information. Because in dealing with this, somebody have talked about making sense out of data. And I will understand that to mean making or turning the data into information. That may probably require filling certain gaps, perhaps when the machine malfunctions or stops. What do we do when the gaps become wide? Are there algorithms that are available that can help those who want to do some analysis, use them to address perhaps a very a large chunk of data where manual computation or identification of outliers, for instance, or gaps, and we use simple maybe means to fill those gaps? Are there not such things that we can be provided with, please, so that we can now say, well, we will have data, we can transform that data to useful information. Please, I'd like you, if you don't mind, address it to concerns of mine.
All right, thank you. And then third question.
Curious to know your thoughts on the role of design and presentation of the data, the packaging of it. Do you see any issues with that in terms of perhaps presenting an air of authority or legitimacy through design? This is something I think about within the context of just general communications of air quality information, but I'm curious in your experience with actual kind of database management. Is that something that comes up?
All right, thanks. I think those are all good questions lead off of each other, actually. So the first question was about a community of practice in developing group standards. And does anyone want to address, Christa? Probably I can.
Yeah, to Nuria's question, I think to the community of practice, I think those often work best when there's a problem to solve, like when they're focused on an issue and people can bring their expertise, instead of it just being a community of practice for a community of practice's sake. This sort of leads into the hard question of how do you actually figure out what that, say, a data standard looks like. I've been part of other efforts that have tried to develop data standards, and it's super messy. As you said, it's not rocket science, but like maybe it's harder then. I think where I've seen it devolve is where everyone wants to include everything, and there's not sort of someone in the room to like cut it off. And it doesn't really end up meeting anyone's needs, and it's not used. What we saw with OpenAQ was there was a lot of value in having, honestly, like the lowest common denominator, what you could get, what information you could get from all the different types of sensors, and then make it clear who you can reach out to find more information for your particular bespoke issue. And I think that what often happens is no one's perfectly happy with what you end up doing, but you need to have a line. I think more than anything, it's important to have the data be findable, so that it's used in global reports and all those sort of things. So I think that's the key. So it's not a perfect answer, but that tends to be where I came up from. And we're just doing the first question right now, right? So I'll turn it over to Nick.
Yeah, please.
Yeah, I think it's a great question when it comes to standardization. I think the important point here is maybe to be like use case driven. Like if you have a specific use case, how do we get to define what's like actionable and usable in terms of the data requirements? What we've seen, I think one of the first use cases we had was we wanted to interoperate the AirQo platform with the UNAP platform. And along the process, then that's when we kind of started getting to a bit of, challenges. We found that the data that maybe the platform was consuming on their side and then on our side required a bit of harmonization. I think there's room for, I think for people to get on, perhaps we don't yet have the critical mass of everyone to get on board, but I think we need to start with something that can be like a baseline, but maybe with an open mind that it's going to evolve, because I think it's so difficult to fix it now. But I think we need to start the conversation, have something well aware that we are going to evolve on this, especially in the absence of I mean, you don't want to push this to the regulator as well, like to say, maybe the EPA of, certain country regulate how the standard is going to be, because they might not have the practical knowledge on what can work. So I think letting the community working together to have something that can work is probably a good approach. Thank you.
Thank you. We have to remember the whole point of having a regulatory standard is so we can intercompare between instrument types and different areas to know that what we're reporting is roughly the same. And points being made by the rest of the panel about a needs-driven document, as the CEN European activity is about, and the UK, I'm sorry to say we have a separate one called SEN for some reason, but fundamentally they're trying to codify operation and understanding of how you run these things. The key there is then that will allow you to compare between sensors, but also allow you to compare between these sensors and reference grade instrumentation as well. And that's obviously going to open the door to widespread use of small sensors for regulatory compliance work. So that's very important to remember. But the other point that Nuria brought up about data is there's a couple of really good examples is in the UK associated with open and free data, completely open to get a hold of, really happy to use. But I usually take about 3 to 5 months to train a PhD student to understand how to use it and open the netcdf file. And what does that column mean? What does that, all right, refer to annex number 42, which tells you, all right, that's micrograms, and it's in an effort to be completely open, completely transparent, and completely interoperable. You make it so complex that it's impenetrable. And that's the other side. And there's a wonderful balance to be made there, thankfully, by other people in terms of how we do that data wrangling, that intermediate data wrangling. But it's very important for small sensors because the groups using it are far more down to the community side in a way that, shall we say, a dual beam photometer isn't something a community is going to be using. We have to also, the regulations need to be looking bottom up rather than top down. If they're too technical and too, well, impenetrable, I say it again, then they're not going to be useful for this wider grouping. And that's the important thing, is that target area, I think, anyway.
Okay,
Hi,
and the
this
next
is
maybe it's
Vasu
for
from
the wider
Vermont.
community here is are we missing anything by focusing on PM 2.5 mostly? And I know that's what's used in epidemiological studies a lot, and it's fairly well characterized by low pass sensors. But do you guys have any thoughts on that? Brief thoughts? Yep. Okay, you nodded first.
Sorry, no, please, no. Oh, you're backing away from this one, are you? Okay. We have to remember that most small sensors at the moment are a function of what technologies we could make work at this scale with these power requirements and at this cost point reliably. There are other sensors which can give us, with the same technologies for electrochems, you can get, for example, SO2, but that's a far less mature technology and can't be deployed as easily as NO2. And they're all not quite as good as the CO sensors at this stage, for example. But in terms of having PM as a proxy, it's a good widespread measurement for now. And as technology improves, we need to push into the ultrafines and wider questions about other species that we're not measuring. Absolutely, we might be missing big things. I mean, I would say that the current focus on exotics such as POPs, pesticides, and other species of that nature is something that we need to be pushing for in this distributed sensing approach, which is what small sensors are part of. But we are limited by technological availability of miniaturized sensors that can be used in that way. Please focus your PhD students on technical developments to try and solve that, because at one point they said the same thing about PM 2.5 in reference relative to PM 10. And then they said it regarding small sensors, and PM 2.5 not going to be possible at a reliable level. And they said it with NO2 and so on and so forth. And hopefully in 4 or 5 years' time, we'll be measuring exotics in the same little box with the same little solar panel strapped to a lamppost as well, to fill those data gaps that will, that could be rather important when it comes to whole life epidemiological studies. Please, someone take it up.
Yeah, just quick comments really on that. I think there's been already quite a bit of I guess studies even from WHO that kind of indicates PM as a good indicator for clean air. But that's not to say that the other pollutants are not important. I think the comments been made by Dr. Ik here is really correct, that I think we're closely watching and hopefully contributing to the building blocks for gaseous and the other pollutants, and see how this space is going to evolve in the next few years. And then hopefully I think it will spur the further works and sensor networks on the other pollutants as well. So I think we had the same discussion here with some people earlier on, that it's really where the technology is currently is, but I think things are going to change quite drastically. I'm optimistic in the few years. Thanks.
Okay, and then the last part of his question and your question was sort of related, I think. How do you translate this data that you get to actual information that maybe scientists aren't using, but policymakers can use, the public can use? And also how you package that data and that information. Are you giving the right sense of confidence or believability? Is that kind of what you meant? Or the opposite, like the wrong sense of confidence? Yep. And so Christa, I think, was volunteered to start.
No, it's a great question. And I think it matters a ton how you graphically display that, and share what you know and what you don't know about the data very candidly. I think this goes into trust with the platform that's providing that data. I think there's several ways to do that. I think, even things like if it's open data provided by an open source project, and being very transparent of pointing to your underlying, like just showing some humility behind the system and that it can adapt from the community. Having things like report errors, things like that, I think are huge. It just shows, this group is being very honest about what they may know and what they may not. I think the other piece, and this might not directly address your question, but I think something of interest to me in this space has been, how can you adapt ways of sharing data, like the front end to different cultural contexts and languages. And I'd love to see an open source project around that could be customizable and adaptable. And I think that could be super powerful for making that information more readily digestible and at the right, setting the right tone and expectations around the data, and also just communicating the data.
Yeah, sure. Yeah, I think in terms of the role of design in the data presentation, that's quite critical. I think you could look at data as, just use an analogy. If you had a tree, let's say you have a tree outside here, you might have, people here, maybe you have air quality like champions, and you might have a carpenter, you might have a mayor. I think different people look at this tree like in different perspectives. So a bird might look at this tree as, something where they want to go and either rest, but a carpenter might want to say this is a tree for timber, and the air quality champions here might say this is a tree for, giving us clean air. So I think when we think about data, we should really put that into that perspective, that knowing that, the data point here needs to be presented in different perspectives for different users, different stakeholders to have impact and value. Thank you.
Well, that's a far better answer than I was going to give, certainly. I mean, in terms of presentation, there's a simple approach of language being used. I mean, if I told maybe my great-grandmother, the PM10 is up today, we need to do something, she'd just look at me blankly, of course, because there's a level of education behind that that's needed. But if I just tell her, Moshi is getting in people's eyes, she'd do something. But I do like the idea of data being accessible in a sort of, not just I can download, I don't mean to do down CSV files downloading. I don't know why I've got a thing about that today, but the data having lots and lots of context around it. This means this is taken from that. Lots of, do you want to know more? Click here kind of elements to it, to allow people to walk through what that particular case study is or that particular story is at a pace that they're comfortable with, as opposed to well, you should know this. We need to avoid that element, and as you say, that humility in providing that messaging is important. There was another point I was going to make, press completely gone. So no, but yeah, without the data getting out there, what's the point of collecting it? We have silos, we have blobs of data, we have all that sort of good stuff. Transferring that into knowledge, that's a whole nother conference. And translating that into a form that's widely usable and is in inverted commas now no longer data but is now knowledge, that's a whole new conference right there.
Thank you very much. I think my professor here was actually talking about a kind of data visualization workshop within a program like this. I think it would be appropriate to have maybe 1 or 2 sessions that borders on data visualization. Yeah, I think basically that's what he was talking about. Then my own question now is, I think Dr. Mead, yes, I don't know if I got this right. You mentioned something about funding of your research, I think in the UK, and you said the districts, you get some funding from the district. I don't know if I heard you right. Please, can you walk us through how you are able to convince the authorities to give you the funding? Thank you.
So mine is a different kind of question. It's a provocation based off of something that Ick said, a different source of data. So here we are talking a lot about, data from sensors and all that. But you alluded to your grandmother, and I'd like to call that indigenous knowledge or the wisdom of our forefathers. In your case, your grandma was only interested in things she can see and feel and knows that they would hurt her. In my case, I had an argument sometime back with my grandma, why she should convert from her three-stone stove. Is that what we call them? And she told me something very simple. This does 3 things for me in one. I can cook, I get light. On a cold day, I get heat. You in your town, fancy town, you need 3 things for all of this. You need a bulb for heat, you need a stove for cooking, I needed something else to heat your house. So my question, how do you argue with such wisdom?
Those are all good questions. Do you want to answer?
Not really, but I'll give it a crack. Firstly, I'd never argue with your grandmother. But no, it's what are the alternatives? What are the solutions? It's very easy to say there's a problem with this, but it's more useful to say, here's what we can do instead. I have to admit, it took many years to convert my grandmother from the stove outside to a G-go that clay we could move. But yeah, indigenous knowledge is important. We shouldn't bypass it in our rush to new technologies and new approaches. The funding question is a bit more complex in as much as initial funding for operational reporting of air quality species is a regulatory and legal requirement in many countries, including the UK. Hence why there was a need for the starting of the reference networks. That was then amplified by community groups and advocates who were noting that pollution was significantly worsening and there was an issue. And one of the turning points was obviously the very sad death in the UK that was attributed directly to air quality, the first in the world. That then led to further push for monitoring. And that push then forced local boroughs and local councils to take action on their local problems. And then that continued to expand into business groups who want to do public good work and individuals who want to make measurements in their own area. So it fundamentally is a point of how big a lever can you put in front of people to say, this is important, this is important, this is important, and pull that lever until you get what you need. But it all starts with ground up advocacy. I mean, even the legal side of things, that sounds like a top-down thing, but at some point, was it back in the 50s when they had the Alkali Directorate in the UK, that was based on not fly tipping soda ash. That wasn't because of public good. That was because it was a valuable commodity they could sell somewhere else. So whatever that driver is, we need to be pushing that educational element that this is bad for your health. This is detrimental to our young people, to our old people. This is a cost burden on our hospitals, our already overstretched medical services. This is costing us this many working hours or working months per year. This is reducing our efficiency in terms of our natural capital. These are all the levers that we should be pulling as much as we can with our government or federal agencies to force a start in some sort of conversation regarding funding and then extending that into the community groups and to see what they're after as well. I'm not sure if that's answered your question exactly. I suppose a simpler answer would be we fought for every one of them to make sure we could get continued expansion based on a reliable and societally important product, that is to say, an understanding of your local environment, which allows you to make differences in your behavior. Please.
The only thing I would add, more of a comment, is so it sounds like you had anchor data to the beginning, and I think that is so key.
But even that anchor data started in the same way as this. It just happened to be that it was in the past, and we seem, if we look at it in, I don't want to make you hold it. If we look at it through the lens of just today, what we have, what it is, what the existence is right now, and we forget how these things evolved, well, what we're doing right now with, in many ways, with the small sensors is not that different to what was done previously with regulatory monitoring to set up these networks in California, in the UK, and so on and so forth. It just happens to be that they were done previously and are fixed. And then we look at it and go, well, that's easy. Someone else, it's been done, it's easy. No, it was just as much of a struggle for them back then and possibly harder. So, you know, we really need to remember that these things are always going to be evolving, and the only way we can get them to continue evolving is find a need and a driver and really push it as much as we can, I feel. Just my opinion, of course.
Hello, can you all hear me?
Yes, I can hear you. Yeah, just a quick comment on the programming. I think the question inclusive programming for discussions like this. Actually, if you look at the program booklet, we do have a session tomorrow for journalist communication, try to sort of like explore how we can move the conversation and include maybe non-traditional scientists in the data conversation. Hopefully that's the beginning of a great journey in terms of bringing more people on board in terms of the data. Just wanted to kind of communicate that. I think there's somebody online. Yes, we can hear you.
Okay.
Yeah, is that a question?
I just wanted, this is Vasu Kilaru calling. I just wanted to sort of reiterate what, a bit of what was said and the importance of making a case at whichever level, whether it's a city or a country, that there are costs to non-action. And I believe IC, sort of brought that out and others have too. And so not doing something about the quality of the air does have its effects and its impacts. And, I don't need to outline them all. Some of them were discussed in terms of the health, monetary, real costs. And so I think that needs to be brought into the conversation. And I'm sure it often is to the policymakers that non-action is an action in a way. You're just choosing to suffer the population to suffer the consequences of air pollution. And so I thought that was a good comment. Thank you.
Yeah, thank you, Vasu. And yeah, it's glad to see that you're able to join. So Vasu is one of the session co-lead as well. Thank you. Over to you.
All right, well, I think we had a lot of good discussions about data, how you access it, how you look at it, communities of practice. And I think everyone here is going to be around tomorrow for more questions or grab them after the session. It doesn't seem like there was anyone else online that wanted a comment. So we'll see you all tomorrow. Thanks very much.
Thank you so much. Yeah, thank you. That was great. Yeah, thank you.